So good morning everyone. Uh, I congratulate Dr. Vipin for putting up the other aspect. I will be going a little into the basics of the newer technology. So I have no financial interest. So as we all know, he's the man behind and what we are talking about, Sir Harold Ridley. IOLs have undergone a sea change since the time Sir Harold Ridley first implanted a polymer lens in the eye to replace the natural crystalline lens of the eye. This is how the evolution that has taken place. This was the journey from here. Now we are here. So I'll go a little into the physics as I just said. This is how the genesis of the diffractive multifocal looks like. It has a two element, a monofocal element and a diffractive element. Monofocal corresponds for the far vision power and the diffractive element for the addition. So the monofocal part can be toric for corneal astigmatic corrections. So I'll be referring to the green nanometers, which is the 555 nanometers, and the power by desired focal length is the add here. So now spacing of this graph controls the power and the height controls the light energy split for a given wavelength. So now for adjusting the height of the steps allows to control the amount of light which is diffracted in various foci. So now adjusting the height max allows to split the incoming light into the one or more component. For one, of course, we'll get a monofocal component. This is achieved via the selection of value alpha, which is the parameter controlling the percentage of the light split. So now if we are looking at a single component, we'll set alpha as 1 and we'll get a monofocal diffractive component. And now if we want to split it into more than one component, we'll have to plan the value as half because it is inversely proportional here. Suppose these width have been adjusted to provide near addition, which was 3.33 as which mentioned above. The lower the order or the more the order it is goes into the waste and it is not much of helpful. So for this particular example, the second order of diffraction provides 4% of the light energy for a very near foci, that is 6.66 add, which is not of any clinical useful. But what if you increase the width and get it adjusted, you get an intermediate of 1.66 and a near add of 3.33 now, which can be clinically useful to us. So I know this is how I felt when I was making it too much of a stress here. So now how do we switch from a bifocal to a trifocal diffractive element? So consider two diffractive elements wherein with two different powers, that is P2 and P1/2. First element is for far and near and the lower one is for far and intermediate. And adjusting the height of these diffractive splits the energy optimally between far, near and the intermediate foci. And here the second order of diffraction light energy is 3.33 diopter and which is useful clinically for the near addition. So now this is how a trifocal diffractive would look like. A non-apodized, again a newer term here. So apodization, basically what does apodization means? It is basically an optical filtering technique and its literal translation, it means removing the foot. It is a technical term for changing the shape of the mathematical function in an electrical signal on an optical transmission or a mechanical structure. So now to apodize would mean what? To apodize is to reduce the height of the steps. This causes progressive shift of the light energy split towards the far when the pupil dilates. So the lower the steps, the more light diffracted in the zeroth order at the expense of the first order, which is what we are aiming at. So now consider the two apodized diffractive elements for far and near and far and intermediate, and then you adjust the height of the diffractive spreads to split the energy optimally between the far, near and the intermediate foci. Herein the second order of the diffraction, the light energy is gives us a 3.5 add, which is useful for the near foci. So now this is how a trifocal diffractive apodized graph would look like. So let's summarize. These are some of the commercially available lenses as told by Dr. Sani, and now one of the most talked about lens is the Panoptix, which is a trifocal diffractive but a non-apodized lens. I would be stressing a little on the Indian company which is making these Tridiff lenses. I have a good number of exposure to them and my patients are doing fairly alright. So this trifocal gives a full range of the vision correction, gives the panfocal vision, balanced distribution of light for the better contrast sensitivity. The spherical aberration correction is to essentially 0 and it's a pupil independent trifocal lens. A high quality vision in all light condition is what is aimed for. This is how the design looks like. So specification we've just discussed, I'll just highlight 2 points. It's a hydrophilic platform, yes, but still doing fairly alright. I have almost 1.5 year follow-up for my first patient, and here in the optical power for the near add is 3.5 and for the intermediate is 1.8, which really matters. So this is how the graph looks like for this particular lens. This is the MTF, the defocus curves for all the three different dioptric corrections available. This is the contrast sensitivity energy scan for the three different pupillary apertures for 3, 4 and 5 millimeters. You can see the three humps, which looks pretty impressive. So now we all know how the pupil behaves in different conditions, the mesopic or the scotopic. Herein, the Weber-Fechner law said if the total loss is less than 10%, then it kind of gets ignored. And this particular lens, the studies have showed that the total loss of light during DT is around 8%. So which improves the patient compliance here. MTF we've just discussed. Now this is a very important thing what this particular company has done is they give you the actual power. Just imagine if you have a emetropic power ranging to 18.92. So now the ordered lens would be a 19 diopter lens, and according to the FDA approvers, the variation what we'll get is a plus minus 0.25. But yes, if you have an actual power which is mentioned there as 18.95 and your emetropic correction was 18.92, you're bang on for the vision part of this particular patient. Scattering of course happens with all the multifocal or trifocal lenses, but yes, what makes this one different or reduces the glare here is the decreasing step height and increasing angulation from center to the edge. This ensures excellent light distribution. To summarize, IDIF and the TriDiff lenses, they provide a panfocal vision, an addition of 3.5 for distance for near and a 1.8 for the intermediate. There is a small video. I'll skip the Zepto part of it because of the time, and it's a easy to be loaded lens. You just need to so maybe from here, this is how a Zepto Rexis looks like. It's a pretty good strong Rexis. I'll just show the loading of the ring. It's a basic loading, simple. You just have to look at the leading left leading haptic has a hole. It's on a plate haptic platform presently. And once you are sure about the visco wash, I'll just show the rings on the higher mag. Looks beautiful inside the eye and gives a pretty comfortable vision to the patient also. Thank you.